In this section 3.4, Shabab, we will talk about the zeros of polynomials, which means in this section, we will learn how to find the rational zeros of polynomials. And also we will learn how to factor polynomials. And we have lots of things to talk about here. But before starting with anything, let's make a small introduction about factoring real numbers, because from factoring real numbers, we will learn how to factor polynomials. Let's read this first question, Shabab. Is 2 a factor of 12?
Yes.
The answer is yes. Why? Because if I divide 12 by 2, the answer is what, Shabab? 6 times 2 is 12. And what's the remainder?
0.
So because what? 12 divided by 2 is 6, and the remainder is?
0.
This is the meaning of factor. So when I say factor, the remainder should be what, Shabab?
Zero.
The remainder should be 0. Now look at the second example. Is 5 a factor of 12? If I divide 12 by 5, the answer is 2. And what's the remainder?
2.
So is 5 a factor of 12?
No.
The answer is no. Why? Because the remainder is what?
Remainder equals.
The remainder is not 0. So when do I say that a number is a factor of another number?
The
If the remainder is
0.
0. This method is the exact same method that we will use with polynomials. So when will I say that a polynomial is a factor of another polynomial? If the remainder is
0.
0. Now, how can I find the remainder? We have to remember what we have taken in 3.3. How did we find the remainder? Remember the remainder theorem? Let's read it one more time. This thing. Read this writing, Ishabel. What do we have here? How to find the remainder? We said to find the remainder there are two ways, either by the division or by the substitution. Okay?
Okay.
Again, what if the remainder is 0?
It's
We say that it's a factor. So let's read this factor theorem. What does it say? The polynomial x minus k is a factor of the polynomial f of x when if f of k is what? 0. Why, ya shabab? This f of k, do you remember what is it? This f of k is the remainder, am I right? The remainder of dividing f of x by x minus k. So if this remainder is 0, this means x minus k is called what? A factor. Didn't we mention this earlier? When do I have a factor? If the remainder is 0. Let's apply this theorem. This is called the factor theorem, Shabab. Let's apply it in our next example. Read it. What does it say? Determine whether x plus 4 is a factor of f of x or not. How do I know if it's a factor or not? We said the remainder should be what? The remainder should be what, ya shabab? If it's a factor,
0.
it should be 0. So how can I find the remainder now?
substitute or division.
Thank you very much. So the remainder of dividing f of x by x plus 4. Do you remember the theorem? What does it say? F of what? What's the 0 for this divisor?
Negative.
So how can I find the remainder? Is the substitution easier here or is the division easier?
Division.
The division is much easier. So I want each one of you now to start dividing and start dividing. Use a pen. Do we have any missing terms here in this example?
Yes.
And we have to replace that by what if it's missing?
0.
Yeah, start dividing.
دكتور زيرو حق ايش يا دكتور؟
The missing term. This is for the missing term, which is x to power 3. Do you see x to power 3 in the question? This is for x to power 3. It's missing.
It's a factor.
Taqi, give us the numbers, ya Taqi. What should I write?
Yes, teacher. The number will be negative 12.
Continue. Give me all the numbers.
Okay, negative 12. It will be
48.
48. Yeah, it will be 0, then 0, 8, negative 32, and the remainder will be 0.
So since the remainder is 0, can I say that x plus 4 is a factor?
Yes, you can.
So we say negative 4 is a 0 of f of x, and at the same time x plus 4 is what يا شباب?
A factor.
A factor of f of x. Why is it a factor? Because the remainder is 0. What if the factor was not 0? Can I say that x plus 4 is a factor?
No.
Of course, the answer is no. Now let's use the same factor, which is x plus 4, and check it with this example. Is x plus 4 a factor of this polynomial, shabab? Yeah, again, I want you to do it. Divide by negative 4. And tell us if it's a factor or not. Of course, the substitution here is very long. The division is much shorter. Muhammad al-Harthi, give us the numbers.
Yes, doctor. 1, 2, 3, 0, 5. Remember 0.
No, it's not 0. Negative 40.
Negative 40. Negative 40. Yes.
So the remainder is negative 40. Is it equal to 0 now, this remainder?
No.
So we say negative 4 is what, Shabab, now? Not a
Factor.
0 of
0.
f of x. So x plus 4 is not
Factor.
a factor of f of x because the remainder was not 0. Any questions? طيب. Let's move on then. Let's read this example. What does it say, Shabab? He says factor f of x into linear factors. F 5 is a 0 of f. So this information, what does it mean? If he says 5 is a 0, does it mean f of 5 is 0 or not?
Yeah.
Does this mean that x minus 5 is a factor or not?
Yes, factor. I think.
طيب. Now, since x minus 5 is a factor, the question is asking me to do what? Read the first word in the question. He says factor. So now how can I find the other factors of this polynomial? I know that x minus 5 is a factor. How can I find the other factors of this polynomial? To answer this question, let me go back to the examples that we started with today. Read the first question. We said, is 2 a factor of 12? What was the answer?
Yes.
The answer was yes. Why? Because the remainder was what, Shabab?
0.
Was 0. Type. If 2 is a factor, what's the other factor of 12?
Also 4.
12 is the product of what, Shabab? 2 times what?
6.
2 times 6. What do we call the 2? Do we call the 2 a factor or not?
Yes.
So is 6 a factor or not?
Yes.
Factor.
So how did we find the 6? Look here. We used what? Division. So to find the other factor, we will use the division. We will divide by the first factor. So since 2 is a factor, 12 divided by 2 is 6. So also 6 is a factor. We will do the same thing now with the polynomials. Is x minus 5 a factor?
Yes.
In this example here?
Yes.
If yes, how can I find the other factors? Yes, anyone?
X minus 5 multiplied by something equal.
Yeah, but I need to find the other factors. We need to what, Shabab? We need to
I think long division.
long or synthetic. Synthetic is much shorter, so we have to divide now. So again, everyone divide, ya Shabab. Look at the coefficients now. Of course, we divide by 5 now, which is the 0 of the divisor. Hassam, what's your question?
لا بس بغيت اجاوب يعني.
I cannot hear you. Your sound is very low. Raise your voice. طيب, Muhammad Al-Galaf, give us the numbers.
30 minus 7 minus 35 minus 3 minus 15, and the remainder is 0.
Thank you. Now, of course, the remainder should be 0. So can I say that x minus, of course, x minus is a factor. Now this thing, you see this thing, Shabab, what's this? Remember the numbers here? We said the -3 was the constant term, and the -7 is the coefficient of x, and the 6 is the coefficient of x squared. So can I write my function in this form now? Can I say that f of x is equal to x minus 5 multiplied by the blue part? What's the blue part now? It's 6x squared minus 7x minus 3. This is our other factor. Type. This blue part now, can we factor it more?
Yes.
We took this in chapter P, how to factor more. We'll 6x squared, I can write it as 2x and 3x. -3, it will be like this. Do you remember how to check the answers, Shabab? We used to multiply the outers and multiply the inners and add. So how many brackets do you see in our final answer?
3 brackets.
I can see 3 brackets. What's the power of x inside each bracket?
1.
It's 1. So we say these are called linear factors. So again, to find the other factors, what did we do, Shabab?
We divide.
We divided. We can, or we solved this question because he gave us one of the zeros. Do you see one of the zeros that is given to us, which is 5? Now, what if this 0, 5 was not given to me? How can I factor? This will be our next discussion. I will go down to that question, which is this one. Where is it? No, I think I skipped it. Here, this one. Read the Shabab. What does it say? Factor f of x. Now, what's the degree of this polynomial?
3.
Degree 3. Now, remember in chapter P, we took how to factor in different methods, but we didn't learn how to factor polynomials of higher degree. So here now we will learn how to factor higher degrees. How to factor? Let's first of all give some names. This -30, do you remember the name? We used to say this is the constant term. And the number 1 here, we used to call this the leading coefficient. Now I will ask you, or we will find first of all the possible rational zeros. So what does that mean? These are the possible zeros. Possible means they may be zeros and they may be not. How to find them? I have to divide all the factors of the constant term divide these by the factors of the leading coefficient. Type. Now, what are the factors of the leading term? Sorry, the constant term. Do you know what are the factors of 30, Shabab?
Yes.
30 is divisible by what? Is it divisible by 1?
Yes.
So 1 is a factor of 30. Is 30 divisible by 2?
Yes.
Is it divisible by 3?
Yes.
5, 6, 10, 15, and what?
30.
And 30. These are what now? The factors of 30. Type. What about the negatives? Their negatives, are they also factors or not? So how many factors for 30 do I have? Count them. Can we count these, Shabab? How many factors for 30 do we have?
16.
16. Now, the leading coefficient is, what's the leading coefficient in this example? It's 1. Leading coefficient. Look at the blue shading. So the factors of that are only 1 plus minus 1. Now if I divide the factors of the constant by the factors of the leading, what will I get? Of course, I'm dividing by 1. This means the numbers, will they change or will they remain or will they remain the same?
Remain the same.
So these numbers that I'm writing, what are they, Shabab? These are called the possible rational zeros. What does this mean? If we have rational zeros, they should be from this set, not from any other set. Now, our second step is to start searching. We need to search for the zeros. How do I search? I have to start substituting. What's my first possible zero? Is 1. I have to find f of now. F of 1. If it's 0, this means x minus 1 is a factor. Yeah, how much is f of 1 now? If I substitute 1 in the function, what do we get? Go up and substitute 1 in the function. We have 1 plus 6 minus 1 minus 30. What's the answer? Is this equal to 0 or not?
No.
So we say 1 is what?
It's not a factor.
Is not a 0. What's our next number in the possible rational zeros? The negative 1. If we substitute negative 1, Shabab, what do we get?
Negative 1.
Minus 1 plus 6 plus 1 minus 30. Is this equal to 0?
No.
So we'll say negative 1 is also what? Not a 0. What's our next possible 0?
Dr.
We
should
have
I
to-
try out the 16?
Sorry? No, I'm just gonna search for one of them.
Okay.
Search for one of the zeros. Again, search for one of the zeros. Now, if I substitute 2, what do we get, Shabab? 8
Yes, Doctor. 0.
plus 24 minus 2 minus 30. Is this equal to 0? Yes.
Yes.
So we'll say what now? X minus 2 is what now? Is it a factor or not?
Yes.
Factor.
Is a factor. So how can I find the other factors?
Division.
We have to divide. So to find the other factors,
Should divide.
we divide f of x by x minus 2. So let's start dividing now. Of course, the synthetic division is very easy. I will divide the polynomial, which is this. I'm just taking the coefficients. I will divide them by what now? By 2. Of course, what will the remainder be, Shabab, if I divide? Ah,
0.
the remainder should be 0, which is this one. It should be 0. If it's not 0, this means there's a mistake in my calculations. So let's put them down here. 1, 2, 8, 16, 15, 30. Is the remainder 0 or not?
0.
What's this green thing? This green shading, what is it, Shabab?
Is a factor.
This is my other factor. So I will say f of x is equal to what now? The first factor that we have found, which was x minus 2. What's my other factor?
X minus 1.
X squared plus 8x plus what?
Okay.
You see them here? Can I factor more? This green thing, can I factor it more?
Yes.
X plus 3, x plus 5.
That's it. And what's the power of x inside each bracket?
1.
So are these linear factors or not?
Yes.
So we are done. We have factored the polynomial. So let me repeat it quickly. What was the steps, or what were the steps that we did? The first step we did was what, Shabab? Is to find the possible rational zeros. How do I find the possible rational zeros? We have to divide the factors of the constant term by the factors of the leading coefficient. Then we have to search for one of the zeros by picking one zero at a time. After finding the zero, we use division to find the other factor, and we will be done. Now you may ask, or you may say that this is a long method. Unfortunately, there's no shorter method. I'm done for today. We'll continue next time.